we want to graph the inequality, or we want to graph all the real numbers x such that x is less than or equal to -1 or x is greater than 5. So what I'm going to do first is graph all the values of x on the number line where x is less than -1. So I'll put in 0 here for reference, and then -1, and I want to graph all the numbers x, or I want to color in all the numbers x that are less than -1. So recall that I draw an open circle at -1, and then my graph will go to the left. Next, let's graph all the numbers on the number line that are greater than 5. So I'll put in 0 for reference, put in 5 over here, open circle around 5 because 5 is not included in the solution set, and my graph will go to the right. So here is a picture of all the numbers that are less than -1. Here are all the numbers on the number line that are greater than 5. I want to graph every number on the number line that is either less than -1 or greater than +5. Well, that's all these numbers together with all these numbers. So the graph I'm looking for looks like this. Here's -1. Here's 5. I want all the numbers that are less than -1 or greater than +5. So this is the graph that I'm looking for right here. It's the graph of the compound inequality x is less than -1 or x is greater than 5. So it's a step-by-step process here, but what you'll find is that once you get used to this, you can be able to leave out these first two graphs and just visualize them. This is all the numbers less than -1. Here's all the numbers greater than 5. My two inequalities are connected by the word or, so I graph everything that I see. Let's look at one where the connecting word is the word and. X is greater than or equal to -2, and x is less than or equal to 4. So I want all the numbers that do this and do this. So I'll put in 0 here for reference. I'll look at all the numbers that are greater than or equal to -2. So here's -2. Put a circle around -2 and color it in. I want all the numbers that are greater than -2. Here I want to graph all the numbers that are less than or equal to 4. So I put in 0. I'll put 4 over here. Draw a circle around it. Color that circle in. I want all the numbers that are less than 4. Now, what I want to do to graph this compound inequality is to graph all the numbers that are greater than -2 and at the same time less than or equal to 4. So greater than or equal to -2 and less than or equal to 4, that's all the numbers between here and here, because it's in here that I find numbers that are both greater than -2 and less than 4. If I'm over in this region right here, I have numbers that are less than 4, but they're not also greater than or equal to -2. And if I'm in this region over here, I have numbers that are greater than -2, but they're not also less than or equal to 4. So when my connecting word is and, what I do is graph the part that's common to these two inequalities. So the graph I'm looking for looks like this. It goes from -2, including -2, up to and including +4. So here is the graph of all the numbers on the number line that are both greater than or equal to -2 and also less than or equal to 4. So when my connecting word is and, I graph what's in between there. Let's look at one more of these problems. Now I have some inequalities here, two inequalities connected with the word and I need to do some solving to be able to see what the graph of the first one looks like and the second one looks like. So here I'm going to add 3 to both sides, and I'll have 2x is less than 11. Divide both sides by 2. I have x is less than 11/2. My connecting word is and, so I'll write that down. Here I'll add -1 to both sides and get 3x greater than -11. Divide both sides by 3. X is greater than -11/3. So I want all the numbers on the number line that are both less than 11/2 and also greater than -11/3. So -11/3 I'm going to write down here, and +11/2 I'm going to write up here. Put circles around each of them. They're open circles because these are strictly less than and greater than symbols, and then connect the middle part right here. So since I know that the connecting word is and, I know I want all the ordered pairs. I want all the numbers on the number line that do this and also do this. Well, that's all the numbers that are both greater than negative 11 thirds and also less than 11 halves. So my solution set is going to look like this, all those numbers that are between those two numbers. Okay, let's look at one last inequality that's called a continued inequality. Negative 3 less than 2x plus 1 less than 5. Now, this stands for, this is just shorthand notation for this. Negative 3 less than 2x plus 1 and 2x plus 1 less than 5. So when I see that I have a continued inequality like this, what it is shorthand notation for the inequality this connected with the word and to this inequality right here. So I'll solve this by whatever I do to the center expression here, I'll do to the two outside expressions also. So first of all, I'm going to add negative 1 to this. So I add negative 1 out here and negative 1 out here. That gives me negative 4 less than 2x less than positive 4. So I add negative 1 to all three members of this inequality. Next, I divide all three members of the inequality by 2 to isolate x here, and I have negative 2 less than x less than positive 2. Now, this is all the numbers on the real number line, x, such that x is both greater than negative 2 and less than positive 2. So that's what this notation stands for, is a compound inequality connected with the word and. So I'm going to graph all the numbers x on the number line that are in between negative 2 and 2, and that's what this inequality looks like, all the numbers that are between negative 2 and 2. So here's negative 2, here's positive 2, put circles around both of them because the inequalities are strictly less than, and then connect them like this. So compound inequalities are inequalities connected with the word and or the word or. If the connecting word is the word or, you just graph everything that you see. If the connecting word is the word and, you only graph the common part, the part that both inequalities have, both graphs have in common. If you see this notation right here, this is shorthand notation for a compound inequality connected with the word and.